The National Electrical Code, or NEC, typically requires a threaded connection for the service entrance. This generally means a threaded rigid conduit nipple should be used to connect the service entrance conduit to the threaded hub on the meter box or main load center. The primary reason for this requirement is to ensure a more secure and weatherproof seal compared to what a threadless connection can provide. Threaded connections are designed to maintain their integrity over time, offering better protection against environmental factors such as moisture and physical stress. In contrast, a threadless connection may be more susceptible to loosening over time due to vibrations, temperature changes, or other external forces. This loosening can compromise the electrical system's safety and reliability. A loose connection can create a safety hazard. Firstly, it can lead to arcing or sparking, which poses a fire risk. Secondly, it can cause voltage drops, affecting the performance and lifespan of electrical equipment. Thirdly, it can expose the electrical system to moisture, increasing the risk of corrosion and electrical faults. For these reasons, the NEC mandates threaded connections at the service entrance to minimize these risks and ensure a safer electrical installation. When installing or upgrading a residential service, carefully consider the NEC requirements for service entrance connections. Ensure that all connections are made using approved threaded fittings and that they are properly tightened and sealed. If there is insufficient clearance to thread the cut end of the conduit directly into the hub, explore alternative solutions that comply with the NEC. Firstly, consider using a threaded adapter or a combination of fittings to achieve the necessary connection. Secondly, carefully measure and plan the conduit run to minimize the need for cutting and threading in tight spaces. Thirdly, if necessary, consult with a qualified electrician to determine the best approach for your specific situation. Remember, safety should always be the top priority when working with electrical systems. A seemingly minor shortcut, such as using a threadless connector in place of a threaded one, can have significant consequences. By adhering to the NEC and using approved materials and methods, you can ensure a safe and reliable electrical service for the home. Always refer to the latest edition of the NEC for the most up-to-date requirements and consult with local electrical inspectors or qualified electricians for guidance on specific installations. The NEC provides detailed guidelines on the types of connectors and fittings that are approved for use in service entrance applications. These guidelines are based on extensive testing and analysis to ensure that the products meet specific performance and safety standards. Using non-approved or incorrectly installed connectors can void warranties, create code violations, and increase the risk of electrical hazards. It is crucial to verify that all materials used in the service entrance installation are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or Electrical Testing Laboratories, or ETL. This listing indicates that the product has been independently tested and certified to meet the applicable safety standards. When selecting threaded connectors, choose ones that are specifically designed for use with rigid metal conduit. These connectors typically feature tapered threads that create a tight, waterproof seal when properly tightened. Ensure that the threads are clean and free of debris before making the connection, and use a suitable thread lubricant to facilitate tightening and prevent corrosion. Proper installation of threaded connectors is essential for ensuring a secure and reliable connection. Firstly, use a pipe wrench or other appropriate tool to tighten the connector to the manufacturer's recommended torque. Secondly, avoid over-tightening, as this can damage the threads and compromise the seal. Thirdly, after tightening the connection, inspect it carefully to ensure that there are no gaps or signs of leakage. If any issues are detected, loosen the connection, inspect the threads, and retighten. In addition to the mechanical connection, it is also important to provide a proper electrical ground at the service entrance. The grounding system ensures that the electrical system is properly grounded in case of a fault, reducing the risk of electric shock. The NEC specifies the requirements for grounding service entrances, including the size and type of grounding electrode conductor and the methods for connecting it to the grounding electrode. Ensure that the grounding system is installed in accordance with the NEC and local regulations. Regular inspections of the service entrance are essential for maintaining the safety and reliability of the electrical system. Look for signs of corrosion, loose connections, or damaged components. If any issues are detected, address them promptly to prevent further deterioration and potential hazards. It is also important to keep the area around the service entrance clear of obstructions to allow for easy access and maintenance. Overgrown vegetation, stored items, or other obstructions can hinder access to the equipment and increase the risk of accidents. In summary, using threadless rigid connectors at the service entrance is generally not permitted by the NEC due to concerns about safety and reliability. Threaded connections provide a more secure and weatherproof seal, reducing the risk of loose connections, arcing, and other hazards. Always follow the NEC guidelines for service entrance installations and consult with qualified electricians or inspectors to ensure compliance and safety. By prioritizing safety and adhering to the applicable codes and standards, you can help protect the people who will be using the electrical system. Consider the importance of grounding and bonding in electrical systems. Grounding provides a path for fault current to return to the source, allowing overcurrent protection devices to operate and clear the fault. Bonding ensures that all metallic parts of the electrical system are at the same potential, reducing the risk of electric shock. The NEC provides detailed requirements for grounding and bonding, including the size and type of conductors, the methods for making connections, and the location of grounding electrodes. Ensure that the grounding and bonding system is installed in accordance with the NEC and local regulations. Proper grounding and bonding are essential for providing a safe electrical system. If you are unsure about any aspect of grounding and bonding, consult with a qualified electrician. The NEC also addresses the issue of corrosion in electrical systems. Corrosion can occur when dissimilar metals are in contact with each other in the presence of moisture or other electrolytes. This can lead to the deterioration of electrical connections and equipment, increasing the risk of failures and hazards. To prevent corrosion, the NEC requires the use of compatible materials and methods for making electrical connections. For example, when connecting aluminum conductors to copper conductors, use connectors that are specifically designed for this purpose and that are properly rated for the application. Avoid using dissimilar metals in direct contact with each other and protect electrical connections from moisture and other corrosive agents. Regular inspections of electrical connections can help to identify and address corrosion problems before they become serious. Look for signs of corrosion, such as discoloration, pitting, or the presence of corrosion products. If corrosion is detected, clean the affected area and apply a corrosion inhibitor to protect the connection from further damage. In severe cases, it may be necessary to replace the corroded components. Electrical safety is paramount in any electrical installation or repair. Firstly, always disconnect the power before working on any electrical equipment. Secondly, use appropriate personal protective equipment, or PPE, such as gloves, eye protection, and insulated tools. Thirdly, never work on live electrical circuits unless you are properly trained and equipped to do so. Fourthly, always follow the manufacturer's instructions for installing and using electrical equipment. Fifthly, if you are unsure about any aspect of electrical work, consult with a qualified electrician. Remember, electricity can be dangerous, and it is important to take precautions to protect yourself and others from harm. Regular training and education on electrical safety practices can help to prevent accidents and injuries. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date with the latest edition of the NEC to ensure that your electrical installations are safe and compliant. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and other sources. You can also find information about the NEC online. In addition to the NEC, many states and local jurisdictions have their own electrical codes. These codes may be more stringent than the NEC in some areas. It is important to comply with all applicable codes when performing electrical work. Consult with local electrical inspectors or qualified electricians to determine the specific requirements for your area. Finally, it is important to remember that electrical work is not a do-it-yourself project. Electrical work should only be performed by qualified electricians who have the necessary training and experience. Attempting to perform electrical work without the proper qualifications can be dangerous and can lead to serious injuries or even death. Hire a qualified electrician for all of your electrical needs. The choice of appropriate conduit types and installation methods plays a crucial role in ensuring the safety and longevity of electrical systems. Rigid metal conduit, or RMC, offers excellent physical protection for conductors and is often used in locations where the wiring is exposed to mechanical damage. Intermediate metal conduit, or IMC, provides a lighter weight alternative to RMC while still offering good protection. Electrical metallic tubing, or EMT, is a thin-walled conduit that is suitable for use in concealed locations. Flexible metal conduit, or FMC, allows for bends and offsets in conduit runs. Liquid-tight flexible metal conduit, or LFMC, provides a watertight seal for conductors in wet locations. The NEC specifies the allowable uses and installation requirements for each type of conduit. Ensure that you select the appropriate conduit type for the specific application and install it in accordance with the NEC. Proper support and securement of conduit runs is essential for maintaining their integrity and preventing damage. The NEC specifies the maximum spacing between conduit supports. Use appropriate conduit straps, clamps, and hangers to securely fasten the conduit to the building structure. Avoid over-tightening conduit supports, as this can damage the conduit. Support conduit runs at intervals that comply with the NEC and the manufacturer's instructions. Proper bending and threading of conduit is essential for creating neat and professional-looking installations. Use appropriate conduit benders to create smooth, uniform bends. Avoid kinking or flattening the conduit during bending. Use a pipe threader to create clean, accurate threads on conduit ends. Ensure that the threads are clean and free of debris before making connections. Practice proper conduit bending and threading techniques to create high-quality electrical installations. Sealing conduit runs can help to prevent the entry of moisture, dust, and other contaminants into the electrical system. Use appropriate conduit sealing fittings and compounds to seal conduit ends and connections. Seal conduit runs that pass through fire-rated walls or floors to maintain the fire resistance of the building. Properly sealed conduit runs can help to extend the life of electrical equipment and reduce the risk of electrical failures. The use of proper wire connectors and termination methods is critical for ensuring reliable electrical connections. Use wire connectors that are listed and labeled for the specific type and size of conductor being used. Follow the manufacturer's instructions for installing wire connectors. Avoid over-tightening or under-tightening wire connectors. Properly terminated wires can help to prevent loose connections, overheating, and electrical failures. The identification and labeling of electrical conductors is essential for safe and efficient maintenance and troubleshooting. Use colored tape or wire markers to identify different circuits and functions. Label electrical panels and equipment with clear and concise descriptions. Properly identified and labeled conductors can help to prevent errors and accidents during electrical work. Regular maintenance and testing of electrical systems is essential for ensuring their continued safety and reliability. Perform regular inspections of electrical equipment and wiring. Test overcurrent protection devices to ensure that they are functioning properly. Measure voltage and current to identify potential problems. Address any identified problems promptly to prevent further deterioration and potential hazards. A well-maintained electrical system is a safe and reliable electrical system. Understanding voltage drop in electrical circuits is essential for ensuring proper equipment operation. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or fail. The NEC specifies the maximum allowable voltage drop for branch circuits and feeders. Use appropriately sized conductors to minimize voltage drop. Calculate voltage drop for long circuit runs to ensure that it is within acceptable limits. Minimize voltage drop to ensure proper equipment operation and extend the life of electrical equipment. Understanding overcurrent protection is crucial for preventing electrical fires and damage to equipment. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity when an overcurrent condition occurs. The NEC specifies the requirements for overcurrent protection. Use appropriately sized overcurrent protection devices for each circuit. Ensure that overcurrent protection devices are properly installed and maintained. Overcurrent protection is essential for protecting electrical systems from damage and preventing electrical fires.